Hi guys, today we are going to review the concepts of similar figures to get ready for our next quiz. So first of all, the definition of a similar figure. Similar figures are figures that have the same shape, but they will not necessarily have the same size, which is what makes it different from congruent. Congruent is same shape and same size. They're identical to each other. Similar does not have to be identical. They could shrink or get bigger. So for figures to be similar, the figures must meet the following requirements. First of all, we could use a series of transformations including translations, reflections, rotations, and the newer one, dilations, to move one figure exactly onto the other. So let's take a look at what that would look like if I asked you to describe a series of transformations to take these two triangles on top of each other. So the first thing I would do is I would probably see that this triangle is bigger than this one, so we do need to shrink this triangle down. So I would probably start with the dilations first. So I'm going to dilate triangle HGE using, identify my center. So I'm going to make my center E here. So I'm going to use this as my center. Using center E by a scale factor. And what's my scale factor going to be? How do I go from this triangle to this triangle? So let's take a look at one of the sides. If I look at this side of this triangle right here, I notice it's 1, 2, 3, 4. And if I look at it down here, it turns into 1, 2. So if I have 4 and I want to get to 2, 4 divided by 2 is 2. So the scale factor would be 1/2. If you want to make it smaller, it turns into a fraction. Okay, if you want to make it bigger, if we were going from the small to the big, the scale factor would just be times 2. Okay, so after we have now shrunk this image down in half, you can now see that it does look identical to that triangle that is below. So this would become our H prime, this would be our G prime, our new points on this new triangle. So what would I do next? My next step would to move this triangle down to here. We don't have to rotate, we don't have to reflect it. It looks like all we have to do is translate it. So we are going to translate, which is to slide, triangle H prime, G prime, and E. And how are we going to translate it? So now how are we going to move it? So we need to move it down. So how far down? 1, 2, 3 down. And how far over? 1, 2, 3, 4 over. 1, 2, 3, 4. So we say translate triangle H prime, G prime, E prime down 3 and to the right 4. And that would move this triangle directly on top. So that's one way you can prove that they are similar to each other. Okay, other things that we can be looking for is we can look at the corresponding angles. So the corresponding angle measures must be congruent. And remember that congruent means what? It means the same. And then also that the corresponding side lengths must be proportional. So what does proportional mean? It basically means that they should increase or decrease by the same scale factor. I'm going to underline scale factor. So let's take a look at an example of these first two triangles here. So let's do some labeling of our points. So first of all, let's identify the angle measures that we are dealing with here. So this angle would be, we'll make this one 40 degrees. We'll make this one up here 60 degrees. And we'll make this one over here 80 degrees. So there's our triangles. If they're similar, then corresponding angles will have the same angle measure. So in our first angle here, which I have represented, we'll do blue. So we're going to have angle A. So this might be a good time to get some colored pencils at this time. Angle A. And so if angle A is over here is 40 degrees, where would that angle be over here? And that would be angle D. And so this one would also be 40 degrees. So there's our first one. And you can see how we represent it with one dash, and then you're also going to see 2 dashes and 3 dashes as we go. All right, so let's move on to the next one. So let's do the one at the top here. So this one here is 60 degrees. That's angle B. And that's going to coincide with angle E. So that will also be 60 degrees. And then the last one, we have angle C, which is 80 degrees, which means over here would be our angle C, was now angle F, which would also be 80 degrees. And what do we know about the angles of a triangle? The angles of a triangle, so angles of a triangle equal 180. So we want to make a little note about that too, so that we can always double check if we added those up, they should equal 180. 40 plus 80 plus 60 equals 180. All right, so there's our corresponding angles. Now let's take a look at corresponding sides. For these, I'm going to use highlighters. Feel free to switch over if you'd like to. Colored pencils will work too. So let's take a look at the first side. So we have this side right here. So this would be side AB. And side AB would coincide would be similar to side DE. Where is that side located on the opposite shape? They correspond to each other. Okay, the next one, switching over. So this is our corresponding here in yellow. So our next one will be, let's do this color. Okay, so we have BC will be our first one, and that'll correspond with EF. So side BC would be the same as side EF, and that we have highlighted in the green. And then finally, our last one, we have side AC would correspond to side DF. AC and DF, and that's our pink. All right, so we look at our corresponding sides, and that's what helps us to get our scale factors. So let's take a look at what our scale factor would look like. We are actually looking at how do we go from one corresponding side to the other corresponding side. So how do we go from 10 to 20? So there's a couple ways you can do that. We can multiply, or we can divide to try to figure that out. If you're going from small shape to large shape, you multiply. If you're going from a large shape to a small shape, obviously you would divide. So knowing that is important. You can also be writing out your ratios of your sides. Ratios are always division problems. So if we want to go from 10 to 20, we'd probably start off with, how do we do that? We'd probably start off with our side of 20. And we're going to divide that by our side of 10. We want the big side to be first and then the small side. Since we are going larger, we want our division problem to be larger. So the bigger number should be on top. And 20 divided by 10 gives you an answer of 2. Now, if we were going the other way, we would put the 10 on top and the 20 on the bottom. And if you did the dividing, you would get 0.5 or 1/2. And that would show you that it's getting smaller by 1/2. So you actually technically could go both directions depending on what they're asking you to do. Okay, so let's finish up the next one. So BC to EF. So here's BC, here's EF. Because we're going from small to big, I'm going to put the big number on top, the small number on the bottom. When I divide, I also get 2. Keep in mind, if you notice, the big number's on top, the big number's on top. You need to be consistent with that, otherwise your scale factors won't look the same. So make sure you're very careful about what side goes where. All right, and then the last one. We have the side of 14, that'll go on top, and then that corresponds to the side 7, and 14 divided by 7 is also 2. So right here you can kind of see how our scale factor of it should be all the same going down. If something is wrong, did you write your ratio incorrectly? Are all your big numbers on top and small numbers on the bottom, or vice versa? What are you doing? So this one would have a scale factor of times 2 to go from one side to the other. All right, and then our last problem is our triangles. What happens if I'm asking you to find a missing side length? So first thing would be to identify which sides correspond to each other. So I'm just going to use my pens or my colored pencils to highlight those 2 sides go together, and then it looks like these 2 sides go together. So as long as I have that, I can be able to write my proportion to figure out where we are going from here. So we're going to do a proportion. So what triangle goes with what triangle? We're going to start with this big triangle here. So we're going to put the purple side on top, and that side corresponds to the small triangle. So this would be the proportion for your large triangle. This will be the proportion for your small triangle. So then over here, the blue side would be 20, and then the corresponding side would be X. So that's how you would set up your proportion. And then you just have to ask yourself, how do I go from this number to this number? So you would do the same thing at the top. How do I go from 12 to 3? Multiply or divide. In this case, we would have to divide. And 12 divided by 4 equals 3. So if I do 20 divided by 4, that equals 5. And that would be the answer to my missing side length. X equals 5. And we could actually put that right into the problem. All right, so those are your note reviews. You are allowed to use your notes on your test. Use this as you're working through your review today. And test is next week, Monday. We'll see you then. Bye, guys.